Assalamualaikum warahmatullahi ta'ala wabarakatuh. We are from K13 and we're going to present our final year design project, which is the title Production of Thymol from Glycerol. The group members of K13 is Fu Hao, Nadhirah, Suhaina, Nazifa, and myself, Mahakim. And the supervisors of our K13 is Dr. Jamaliah Muhammad Jahim, Dr. Muhammad Saiful Sajab, IR Amiza Surmi from Petronas Research, and also alongside with Muhammad Khaide Abdul Hamid from Petronas Research. Next. So for the introduction is our product is Thymol. So for the physical and chemical properties, molecular formula of Thymol is C10H14O. Molecular weight is 150.221 gram per mole. Melting point is 49 to 51 degrees Celsius. Boiling point is 232 degrees Celsius. Flash point is 102 degrees Celsius. Density is 0.96 gram per centimeter cube. And the specific is 9.76 joule kilogram per Kelvin. So for the usage of Thymol is an antiseptic in mouthwash and as an alcohol solution and in dusting powders for the treatment of tinea or ringworm infections, and as a medical disinfectant and general purpose disinfectant, and also as a rapidly degrading non-persisting pesticide. And the related chemical equation is according to below, which is deoxygenation and deoxygenation and also alkylation chemical equation. Next. And so for the supply and demand, the global Thymol demand is 404.2 kiloton per year, and the Thymol supply is 303.2 kiloton per year, and Thymol deficiency is 101 kiloton per year, which is same as 11,529.68 kilogram per hour, and the maintenance is for 10 days, which is same as 240 hours per year, and the production time per year is 8,520 hours per year. So our overall plant capacity is 2,305.5 kilogram per hour, with same as 19,642 ton per year. Next. So for our conceptual design level 2, 3, and 4. So for level 2 is the overall process. The input of our plant is glycerol, hydrogen gas, and also amcrazole. And the output is amcrazole, thymol, propane, and wastewater. So for the level 3, we use continuous stir tank reactor as our reactor. And for the level 4 conceptual design, we choose phase separator, flash distillation, and also distillation column. Next.
Next is about economic potential in our production. As we can see, here is the graph illustrate the trend of economic potential versus conversion from level 2 up until level 4. The blue line indicate the trend of economic potential from raw materials. So economic potential from level 2 is bring up to level 3 together with the total reactor and compressor cost, which we indicate with the orange line. The total cost of 6 reactors is around 13 million, while cost for 4 reactors is around 2.1 million. Last is the grey line. The grey line is the trend of economic potential 4, where it is related to the separation unit cost, where the cost is around 5.9 million. Next. Here is the economic analysis, which is involve our total capital investment and total product cost. Here is the breakdown of the cost from each aspect. Total capital investment is around 98 million, which is including the fixed capital investment, working capital investment, and land capital. Fixed capital investment is actually direct cost and indirect cost, which is 45.5 6.9 million and 6.6 million respectively. Next is the total production cost, that is involved cost of manufacturing and general expenses. We spent around 85.2 million for our manufacturing costs, while for general expenses we spent around 573,000. Next. Okay. Here is the summary of economic analysis. Our MARR is 0.2 while our ROI is 0.53. It is acceptable for plant operation since the ROI is larger than MARR value. Next is our payback period reference is 3.5 years while our project payback period is only 1 year. It is valid since our payback period reference is larger than our project payback period. Net present value for this project is around 161 million. By calculating our gross profit margin and net profit margin, we decided and agreed to set our Thymol sale price to 10 ringgit per kilogram. The total income and the expenditure in the design plan is considered to determine the breakpoint, which is at 0.95 years.
Okay, for process description, basically we have three chemical reactions, which is hydrodeoxygenation process, deoxygenation process, and alkylation process. For first process, we'll have glycerol react with hydrogen to produce propane and also water. And the second one, we have propane to react to convert into propylene and hydrogen. And the third one, we will have propylene react with Glycerol to produce our main product, which is Thymol. So for these three reaction, we will require high temperature and pressure as stated at the table here. Then what the catalyst we use for the reaction is white alumina and also zinc aluminate. Next. This is our process flow diagram before heat integration. And next. Then this is our process flow diagram after heat integration. Next.
This is our heat integration analysis. We have 4 cold streams with 2 hot streams. We use table problem method in this analysis. Here is the pinch point analysis for above and below stream. Next. Minimum heat load for hot stream is 20.29 kilowatt, while minimum heat load for cold stream is 19.82 kilowatt. Our pinch temperature is 120 degrees Celsius. Pinch temperature for hot stream is 130 degrees Celsius, and pinch temperature for cold stream is 110 degrees Celsius. After heat integration, our total energy recovery is around 18.51%. Next. So this is the PNID after heat integration, where all the controllers are set up at the crucial part.
Next is the process controller. The objective to implement a control system is to ensure the safety of the plant and to achieve a stable production rate as well as a desired product quality. For temperature controller, unit involved is reactor 1, reactor 2, reactor 3, reactor 4, reactor 5, reactor 6, flash column 1, flash column 2, distillation column 1, distillation column 2, and furnace. For pH controller, unit involved is reactor 1, 2, 5, and 6. Pressure controller unit involved is reactor 1, reactor 2, reactor 5, reactor 6, separator 1, flash column 1, flash column 2, and furnace. For level controller, unit involved is separator 1, distillation column 1, flash column 1 and 2, distillation column 2. For composition controller, the unit involved is distillation 1 and distillation 2. Next.
Next, for process safety, three regulations are applied for our plant process. Firstly is control of industrial major accident hazard, TIMA, 1996, because we use hazardous substance in the process, which is hydrogen with 932 tons. Since our plant process hazardous substance more than threshold quantity, then our production plant is major hazard installation MHI. Next is Safety Health Regulation 1997 is applied because our project is a chemical industry with more than 100 employees. Lastly, Factories and Machinery Regulation 1986 in Regulation 5 and Regulation 10 are applied for our plant process. For hazard system, source, receptor, transmission paths and barriers are identified in our process, where the sources are the equipment and components for our process, while receptors are residents, workers, customer and building. Next is high rec. In our process, level of risk is high, which is 15 in the reaction in reactor is next in air pipe inlet. The level of risk is low, which is 6. And flash vessel and pumping of propylene into vessel. The risk level is 9. Both flash vessel and pumping of propylene into vessel are in medium risk level. We recommend to do control the risk by doing installation of leaking detection on pipe, schedule inspection and maintenance on pipe, and install high temperature alarm and emergency response plan. Next is plan layout. Raw materials such as glycerol, hydrogen and M-cresol are placed at the middle to reduce the loss potential from an explosion or fire that may spill flammable. This area also categorized as restricted area. The production site is located at the middle beside to raw material storage of the site to minimize any incidents such as fatality and damage. The waste treatment facility, which consists of wastewater treatment plant, is located at beside of production plant. Many hazardous substances are located in this area.
Okay, for waste management part, basically we have two types of waste, which is waste gas and wastewater. For waste gas, is our propane that can be purged because the concentration that released in an hour is about 179.24 ppm, which is less than 5,000 ppm. For wastewater, effluent consists of water and glycerol, will be sent to the wastewater treatment due to high COD and VOD. For propane, the mass flow rate is 23.96 kilogram per hour. For our wastewater, the total flow rate is about 211.33 kg per hour. So for our catchment area, will be at Sungai Chewang, and the wastewater treatment plant will process the waste according to the standard bid based on the environmental quality Industrial Effluent Regulation 2009. So for organic matter present in effluent is consist glycerol. For assumption, first molar density of the waste stream follows pure water. The BOD value is assumed to be 0.5 of COD value because the glycerol is biodegradable. So the parameter we will be testing is the pH and BOD and also COD, which is 1.5 pH, 45,249.65 mg per liter. For COD level is 90,499.30 mg per liter. Next. So this is the process flow diagram for wastewater treatment. So we'll go to the equalization tank to neutralize the pH by adding the lime water. Then we'll go through 4 of the aeration tank to oxidize the organic matter. Then then the wastewater will go to the primary clarifier to sediment the biomass and also recycle it. Then after the wastewater go to the chlorine disinfection to reduce the pathogen, then the water is treated. Next. Next. For waste minimization, recycle stream for the mass flow rate of the glycerol should be increased to minimize the wastewater being treated. Second, conversion of our brain reactant glycerol should be increased by replacing other suitable catalysts. And the third one is maintenance and replacing new catalysts in reactor to maintain high conversion of reactant. Next. Next, for this is the design criteria of wastewater treatment. This is for the out of the tank and the retention time. Next. This is the efficiency of wastewater treatment. So we success to reduce the COD and BOD level under the requirement based on the standard B. Okay, next.
So as a conclusion, our plant is producing thymol in accession form. We are using glycerol as our raw material. The plant capacity of our thymol is 2,305.5 kg per hour, which is equal to 19,642 tons per year. Wastewater treatment is carried out biologically since our wastewater effluent is biodegradable. Wastewater is able to be treated as the COD and BOD is 35.35 mg per liter and 70.70 mg per liter respectively, which is under limitation required to release according to the standard B. Finally, in economic analysis, the estimated capital investment and total product cost is RM 98 million and RM 85 million respectively. The estimated payback period is 1 year and the net present value show a positive value which is RM 160 million. Meanwhile, the discounted cash flow rate of return is 0.492. Plant location was selected based on a deep geological research which is in Perdana Industrial Park, North Port Klang, Selangor. All the factors of a good location for a plant is considered before finalizing our plant location. That's all from us. Thank you.